Today we're going to talk about matrices and how to perform basic operations between matrices. So first let's talk about what is a matrix. A matrix is an array of numbers in columns and rows. Matrices are used to solve systems of equations. If we look at the matrix on the right, the vertical numbers are the columns and the horizontal numbers are the rows. Next, let's talk about the entries of a matrix. The entries of the matrix are the numbers inside the matrix. For example, if we're talking about matrix A, we would say A, and then there'd be two subnumbers X and Y. X, or the first number, always refers to the row of the matrix. Y is always going to refer to the column within the matrix. So, for example, I'm going to look down at this fourth example, A31. This is asking me what entry is in row 3, column 1. So if I go to row 3 and I go to column 1, that would be 10. In the second example, if I go to row 2, column 3, that would be -8. So we describe matrices by talking about their position. Next, let's talk about how we describe the dimensions of a matrix. The dimensions are how we describe the size of a matrix. For example, if we look at the examples on the right, the first one would be a 1/4 matrix. This is because when we are describing the size of a matrix, we always talk about in terms of rows by columns. So the second one has 2 rows and has 5 columns. This last one has 3 rows and 3 columns. So when we're talking about the dimensions of a matrix, we're describing the size based on the number of rows by the number of columns. Now, let's talk about how we add and subtract matrices. When we add and subtract matrices, we need to make sure that the matrices are the exact same size. Or exact same dimensions. If our matrices do not have the same dimensions, then we cannot add and subtract them. So when we add and subtract matrices, we're going to add or subtract the same spots. So for example, if I have -5 in this first row, first column, I'm going to add it to this -3 in the first row, first column of the other matrix. So my first entry would be -8. I'll continue to do this with all the other entries. So 8 plus -4 would give me 4. -9 plus 0 would give me -9. 7 plus 8 would give me 15. 0 plus 6 would give me 6. 12 plus -5 would give me 7. Now, in the second one, it looks like the matrix are a similar dimension, but they're actually opposite dimensions. The first matrix is a 2/3. The second matrix is a 3/2. Therefore, it is not possible to add these. So we cannot add these two matrices together. Now subtracting is going to work the same. I'm going to subtract the same spot in each matrix. So I'm going to subtract this first entry, 3 minus 0, will give me 3. -6 minus -2 will give me -4. 4 minus -4 will give me 8. And -7 minus 6 will give me -13. The next thing we're going to talk about is scalar multiplication. So in this first example, it says 2c. This means that we're going to take 2 and multiply it by the matrix C. So 2 times 0, -4, 3, 7. Therefore, what we're going to do is we're going to take -2 and multiply it by every entry within C. So 2 times 0 is 0, 2 times -4 is -8, 2 times 3 is 6, and 2 times 7 is 14. Go ahead and try this next example. Try A minus 2B. This combines the subtraction we did above as well as scalar multiplication. Pause the video now, give it a try, then play the video again to check your answer. So what I did was I chose to change it, instead of minus 2 times B, I changed to plus -2 times B. This allowed me to distribute a -2 into matrix B and then add A and 2B together. So the final answer you'd have gotten should have looked like this: -12, 21, 11, -23. Now we're going to talk about multiplying matrices. Now this is a little bit more complicated than adding and subtracting. We cannot just multiply the same spots. So when we multiply matrices, we actually multiply the rows in the first matrix by the columns in the second matrix. The first matrix, we're always going to work left to right. The second matrix, we're always going to work top to bottom. So for our first spot, I'm going to do 2 times -2, because I'm starting with the first entry. So 2 times -2 is -4. But now I need to add that to 3 times -6, which is -18. So notice how I slid to the right and I slid down, because I'm multiplying the first row by the first column to get my first entry. Now, I'm going to do the similar thing to get the second column of the first row. Now, I'm going to reuse the first row values. So, I'm going to reuse this 2 right here, and I'm going to multiply it by this 1. So when I do that, I'm going to get 2 plus 24. So I'm going to do 2 times 1 plus 3 times 8. So I'm going to use the first row and I'm going to multiply it by each column, and that gives me the first 2 spots in my matrix. Now I want to get the bottom 2 spots in my matrix. So I'm going to use the bottom row of the first matrix and I'm going to multiply it by the first column. So again, I'm going to start back on the left. So I'm going to do 4 times -2, so that's -8, plus 5 times -6, which will give me -30. Now, to get my last spot, I'm going to multiply the bottom row by the the right column. So I'm going to reuse the 4 and the 5 again. So I'm going to do 4 times 1, so that'll give me 4, plus 5 times 8, which will give me 40. Then to finish my problem, I'm just going to add each of the pairs of numbers together. So my final answer will be -22, -38, 26, and 44. Now, when we multiply matrices, it's really important that the columns and rows match up so that way we're able to multiply them. So in this example, this is a 2 by 2 matrix, and this is a 2 by 2 matrix. So I'm able to multiply these matrices because my columns and my rows line up in the middle. So the 2's in the middle are the same. My outside 2's in this case tell me the size of my answer, which we can see over here as a 2 by 2 matrix. So for example, I'm actually going to skip this first example to kind of go through a different example. So if I gave you a matrix like this, this would be a 2 by 3 matrix. That means that the matrix, if I want to be able to multiply it, has to have a 3 to start off with. So it's going to be a 3 by something in order for me to be able to multiply it. So 1, 2, 3. So for this example, I did a 3 by 3. Now, Again, the middle numbers have to match, so the 3's match here. The outside numbers would tell me what my answer would be. So in this case, my answer would end up being a 2 row by 3 column answer. So let's give this one a try, even though I just made up the numbers. So I would first always do the row times each of the columns. So I'm going to start off by doing 1 times 1, so that would give me 1, plus 2 times 2, which would give me 4, plus 3 times 3, which would give me 9. So that would be my first spot. Now, to get the second spot right here, I would need to multiply again the first row, but by the second column. So I'm going to do that now. So first row, so 1 times 4 would give me 4, plus 2 times 5 would give me 10, plus 3 times 6 would give me 18. Now to get the third spot, I'm going to do, again, the first row again, but by the last column of the second matrix. So I'm going to do 1, 2, 3 times 7, 8, 9. So 1 times 7 is 7, 2 times 8 is 16, and running out of room here, 3 times 9 is 27. Okay. So now to get the bottom row, I'm going to take the bottom row and multiply it by each of the columns of the second matrix. So I'm going to do 4 times 1 is 4, 5 times 2 is 10, 6 times 3 is 18. Then I'm going to, again, multiply that same row again by now the middle column to get this spot. So 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. Now I'm going to do the same thing, do the same bottom row, now multiplied by the last column. So 4 times 7 is 28, 5 times 8 is 40, 6 times 9 is 54. And then I would add those together to get my final answer. Once we added each of those spots together, our final answer would have looked something like this. Now, I want you to give the 3 matrices down here a try. When you think you have your answer, replay the video to check your work. Remember, you're multiplying the rows of the first matrix by the columns of the second matrix. All right, now check your answers. Remember, multiplying matrices can be tough. It just takes lots of practice.